Today we will see type 3, that is below dredge line soil is cohesive. Now we will consider one problem which is asked in May 2017 for 5 mark. So consider this is the sheet pile. Height of sheet pile is given 5.6 meter. Here we have to find out depth. Now here given values are gamma 20 kN per meter cube, phi angle of internal friction 30. Below the dredge line, the soil is cohesive. Above dredge line, the soil is cohesionless. Here value of C equal to 0 and here value of phi equal to 0. Below dredge line, the value of cohesion 35 kN per meter square. First, you have to draw the pressure distribution diagram. This is the sheet pile. Above dredge line, soil is cohesionless, so the pressure distribution is like this. It is triangular and maximum at point B. Net pressure just below the dredge line, it is given by rectangular like this. Further it goes on decreasing, it becomes 0, and in this way it goes on increasing and it is maximum at the base. Now here first of all we have to find out what is the pressure intensity at B, then net pressure at B and the pressure at C. So here we got the passive pressure at B. So it is nothing but Ka gamma H. So 1 by 3, this is the value of Ka, that is 1 minus sine 30 upon 1 plus sine 30 equal to 1 by 3. Gamma 20 and H is 5.6, so it is 37.33 kN per meter square. Net pressure at B, it is 4 times cohesion minus gamma H. Cohesion 35 minus gamma 20 H 5.6, so it is 28. Now the active pressure at C means this pressure, so it is 4C plus gamma H. 4 times cohesion 35 plus gamma 20 into H 5.6, so it becomes 252 kN per meter square. Now here we have to find out the force due to this pressure distribution, that is P1, area of the triangle. Now P2 means force due to this pressure distribution. Here I have considered this as a rectangular pressure distribution, that is 28 into D. And again force P3 due to this pressure distribution, it is triangular, so it is nothing but 1 by 2 base, this base into this height Z bar. So it is calculated here. Now here use equilibrium equation summation x equal to 0, that is plus P1 minus P2 plus P3 equal to 0. From this calculate value of Z bar. So here I will write Z bar. So here you will get Z bar equal to this value 0.2D minus 0.746. Now calculate Y1, Y2 and Y3. So what is Y1, Y2, Y3? Means distance of this force P1 from base C. This is Y1. So what is Y1? We know this depth D and this height, it is 1 by 3 of 5.6. Then Y2 means distance of this P2 from this point C. So this total height is D. Of course it will act at a distance D by 2. And Y3, that is the distance of this force P3 from base. So it is 1/3 of this height Z bar. So here I will write Z bar. Now here we will use the equilibrium equation, that is summation of moment about C equal to 0, P1 Y1 plus P3 Y3 equal to P2 Y2. Now here we know what is P1, P2, P3. These values we know. Also we know Y1, Y2 and Y3. Put values here. Here we have considered clockwise movement equal to anti-clockwise movement, and I have equated this. Now in this equation you can put the value of z bar, which we have calculated already. Instead of z bar you can write this value 0.2d minus 0.746, it's a square. By simplifying this you will get this equation. Solve this equation, you will get value of d 9.4. Increase this value by 30%, that is 1.3 into 9.4, it becomes 12.22 meter. So this is the depth of embedment which we have to find out. Now next we will see type 4. So type 4, it is related with anchored sheet pile. Anchored sheet pile, so this is anchored sheet pile. Here one anchor rod is provided, that means pull is applied on this pile, so always you will find there is a tension in this anchor rod. Here position of anchor rod is given from the earth level, it is at 1 meter. Now here height of this sheet pile from ground level to dredge level, it is 5 meter. We have to find out what is the depth of embedment. Now this is type 4 anchored sheet pile driven in granular soil. The soil is granular, having value of phi 28 and gamma 24 kilonewton per meter cube. Now first of all you have to draw this pressure distribution diagram. So it is just like type 1. This is triangular, and again passive pressure is also varied triangular way below the dredge line. Pressure at the base, it is given by Ka gamma H plus D. Passive pressure, it is given by Kp gamma D. Now first find out active pressure at B. So it is Ka gamma H plus D. Ka 1 minus sin 28 upon 1 plus sin 28 plus 24 plus H is 5 plus D. Put values here, you will get this value 8.66 into bracket 5 plus D. Then find out passive pressure at B, that is Kp gamma D. Kp means 1 upon Ka gamma D, 66.6. Now here find out active force due to this pressure distribution, triangular pressure distribution. Find out active force, that is area of the triangle 1 by 2 base into height. So by simplifying this you will get the value 108.3 plus 43.32 d plus 4.33 d square. Now similarly find out passive force, that is area of this triangle. So it is 1 by 2 base into height. Now here what is main thing, you have to take moment of all forces, means Pa and Pp, about this anchor rod level, that is at point C. This is the main difference between type 1 and type 4. We have to take moment at anchor rod level, that is at point C, so that one unknown can be eliminated, that is T. Now take moment about C. Pa into y1 plus pp into y2. Y1 means distance of pp from point C, so we can calculate y1. So it is 5 plus d into 2/3. So 5 plus d, 2/3 of 5 plus d, from this deduct this my 1. Okay, so that you will get y1. Then y2 means this distance. So this height is 5 minus 1, this is 4, plus what is this distance, 2 by 3 of d. So like this we can calculate y1 and y2. Put values in this equation. So you will get this equation. Solve this equation, you will get value of d 2.14, increase d by 30%. So d equal to 2.78. Now here you have to put value of this D 2.14 in above equation. So you will get PA and PP. Then use summation H equal to 0, that is minus T. So I have taken this as a minus, plus PA minus PP equal to 0. Unknown is T. So we have to find out T. We know P and PP, put values, will get value of T. So here you have to find out depth of embedment and tension. Thank you.